Hi there folks, welcome back to the dungeon, and today, in response to a request from the Facebook group by Ralph Ulbrich, he asked if I could show how I have connected up my oscilloscope to the antenna connection of the radio to look at the transmitted waveform on the oscilloscope. So that's what we're going to be doing today. So I've got my faithful old Stalker 9 here, and at the moment it is running into my stable lock test unit. And as you can see over here, there goes the antenna cable, the coaxial cable, and into the unit. And here's where I want you to have a look at the input. So what I have over here is the main high load input. It's a 50 ohm load, and it can go up to about 50 watts of input, and then it runs up into the test bed for measuring power. So when I do a transmission, there I get my power indication, 14 point something watts. It's still warming up, so it takes a while to react. There we go. So that's that. Now what I see over here is I have in between the input and another connection, it is actually a 20 decibel pad, which is very useful for me, because then all I have to do is take an RF feed up and up and up. Yesterday I was using that scope, but that's not the scope I usually use. I normally use my old analog scope, and I'll show you why. You'll see how nice this trace is compared to the digital scope. You can very nicely see those Christmas trees over there. 1, 2, 3, 4, 3, 2, 4, 5, and I'm getting a nice trace. So that is the one method. However, not everybody has one of these things at home, so there has to be another way. So let me just set up for the other way, and then I'll be right back. So what we have over here is a repurposed pickle jar. It had some kind of preserve in it that we got from Aldi, and we ate the contents, and the rest was left to me. And inside of it you can see I have, I don't know if you can see very clearly, there you can see them, a whole lot of resistors. So what I have over here is a bunch of 47 ohm resistors. There are 8 of them that I've connected series and parallel, so that 8 of these 47 ohm resistors, 4 in parallel and then 4 again in series, give me my original 47 ohms, which is as close to 50 ohms as a set of conventional resistors is going to give you. So these resistors are installed into this jar, and then I have taken transmission fluid that you can buy from any gas station, normal transmission fluid that I use here as a cooling agent, and it is also not conductive, so it's not going to cause any problems. And now I have as close as I can get to a homemade dummy load. So, you know, for you technically minded guys, you'll be able to work out how to do these series parallel connections. Otherwise, it's time for you to do your own homework and work out how to do that. But that's it. It's an effective 47 ohm, which is close enough to 50 ohms for short tests. So now I have a dummy load, but that's not going to be enough, because I still have to have a way to have a look at those signals. So I'll be back with the next step. Right, so what I've done is I've found myself a length of household electrical wire that's about 2 meters long, and I've wrapped it round and round and round and round and round and round and round till I have used it all up. And I've got this piece coming out the one end over here, which I can set it any way I like, but I can connect a crocodile clip on there, and I can connect a crocodile clip on this one, and there the two of them are together. And I can run that up to my oscilloscope, and this will theoretically pick up the transmitted signal. So let's see how that works out. Alright, so now I have a coaxial connector coming out of the back of the CB through the cable and into the inlet of my homemade dummy load. And now I have my oscilloscope probe, which I'm going to connect the ground to one end of my coil, and then the probe tip to the other end of the coil. Come on, stay on there. It's being a bit stubborn now. There we go. So that now, when I transmit, I might just get to see something, and I do 1, 2, 3, and I'll show you in a minute. But that is working just fine. 1, 2, 3, 4, 5. That's working great. That I can see on the display of the radio that the RF is going up, showing some power. And now let's get a look at my oscilloscope as well. So coming up to my oscilloscope, excuse the clicking, but there it is. Input on the oscilloscope, it's set to 1 volt per division, so that's pretty good. And I'm getting a nice tidy display. 1, 2, 3, and there's my Christmas trees. Tree, 1, 2, 3, 4, 4, 4. And so there's your other way of doing this. Now, I know that you can open the radio as well, and where the coaxial feed comes off of the circuit board, you can connect the tip of your probe directly on there and put it on times 10. If you have a look at this one now, it's on times 1. Where is it? It's on times 1 at the moment. You can select times 10 and connect your probe directly to the output, as long as you run into a dummy load. And I cannot stress this enough. If you're not running into a dummy load, you're going to blow up your transmitter. Especially on these older radios, they use the old type transistors on there, and they don't like a bad SWR. And when you're not running into a 50 ohm load, you're going to have a bad SWR and you're going to have a blown transmitter. So please be very, very aware of that first. Make your dummy load. Be patient with this. Make your dummy load, and then make up your coil, connect it as I've shown you, and you'll be able to do your testing very nicely. So all I'd like to say, Les, is thanks for watching, and we'll see you on the frequencies. Stay safe for now. Bye.